Assalamu alaikum. No, basically there is some shortage of time. That's why sir is not here, and I will continue this session. So we are talking about the Granger causality. I think so. He explained very well, and there is no need to extend that topic. If there is a problem, please let me know. Then I will explain that part of the Granger causality. So, Tumani asked the question: is that cause and effect? Yes, it's all about the cause and effects. And if we talk about the Granger causality, suppose we have two events. One event is A and other event is B. So some is the cause and some is the effect of. Suppose A is the cause and B is the effect. So you can say that if there is a snow, then there is a problem on the road and there is some other thing. So the floods in Pakistan is a cause of destruction of government properties, pools, infrastructure, roads, and you can say that the infrastructure of related to connectivity, all the infrastructure are damaged due to the floods. So flood is the cause and damage is the effect of that cause. Basically, Granger causality is not a very simple concept, but indeed, if we want to learn about the cause and effect, then there is a one example which is I am giving you is A is a cause and B is the effect. But sometime in our country and some other countries in the world, due to some circumstances, there is a reverse effect. Suppose effect is before the cause. Like if we are talk about the Eid, we are going on shopping before the Eid. So Eid is the effect and shopping is the cause. So effect is before the cause. So it can also be possible. So there are some, you can say that there are some versions of Granger causality. So this one is the Granger causality with the lag values, like in which we are saying that yt depends upon its own lag plus the lags of other variable. We have no concern with the lag of yt in this regression. But because it is an autoregressive process, that is why we are adding the lag of dependent variable. Otherwise, our concern is the lag of independent variable. Which one is xt? Xt minus 1 and so on, xt minus p. So, if this condition break down into two things, suppose one, y depends on the lag of its own lag, so there is a no cause and there is no causality. It's a, you can say that the past pattern of the yt. But if the previous value of xt affecting the yt, it means that the previous value of the independent variable is affecting the current value of other variable. So like yesterday sir asked about the consumption theories. If you remember that, he gave an example of income and past behavior of consumption. So there is a Granger causality. If previous year consumption is a cause of change in current consumption, so this is the Granger causality. But the past pattern of CET, your consumption, is not a Granger causality, it is the past pattern of the variable. So this is the distinction between the two variables. So you can impose the restriction, like if I am imposing the restriction on the variable of x, that x is a cause of y. If there is a cause, then these variable will be significant. Otherwise, if they are insignificant, it means there is no Granger causality from the side of xt to yt. So Another version of this Granger causality is instantaneous Granger causality with current term of xt also. So they just include xt as an extra variable. So it means the current value of other variable is also in the regression. So it looks like a ARDL model because there is other variable and there is the lag of other variable. So it is autoregressive and distributed lag because the lag are distributed in independent and dependent variables. So this one is another version of Granger causality. Yes, reverse is also possible. If there is a reverse relation between two variables, then we can say that there is a bidirectional causality. Like, if we are going to give an example of QD is a function of P. So it means that price is the determinant of quantity of demand. But in special circumstances, you can see that they have no concern with price because they are ready to pay any amount of that good. So we can say that the reverse is also possible. But the literature is still confused in this relation. Either P is independent or Q is independent. But yes, non-causality if there is no causality. Basically, Granger causality is a pairwise causality and it is a bivariate causality. So there is no multivariate version of this causality function. So if you are trying to run with multivariate variables, so it makes a pair of each independent variable with dependent variable and check the cross relation between dependent and independent variable. Suppose we have xt, zt, wt and some other variables. So the first combination or first pair of the equation will be yt does not affect, xt does not affect yt, then yt does not affect xt. So this one is the first pair of the equation. So they are trying to estimate the cross relations, you can say that bidirectional causality between the. So according to Granger, this is not a causality, this is a descriptive stats, which shows that the direction of relation. There is no sense of causality. In my PhD course, I taught my student that the causality could not be possible to estimate with numbers because it is a theoretical behavior, totally subjective behavior, and it has latent variables which are not directly observable. Suppose you are trying to estimate the causality at some extent, you must have some other variables related to this, but you are including on those variables on which the data is available. So it means, what about the other variables? Causality means the perfect relation. So there is no perfect relation in econometrics. So that is why, according to the econometrician who are very well known, like Dr. Sussman, Friedman, and other ones, the causality is impossible through numbers. But they are trying to estimate the direction of relation. So that is why we are saying that Granger causality. We are not saying the causality. If suppose x causes y, then we can say that x Granger cause to yt. This is the interpretation of this test. We are quoting Granger because we are saying that it is a description, it is a direction of relation, it is not a causality. So So the latest version of the causality is Yomoto, so you can also uh, see it in the textbooks. It's all about the ARDL modeling. They include the other variables and they try to estimate the pairwise F test for the variables, because if these are the 6 legs of y, suppose x. So according to the theory, they are not going to estimate each leg. They just find out the F test, joint significance of the leg value, and give the result. So basically, today my topic is to find out the estimation method for financial econometric theories or financial econometric series. Basically, there are so many methods in financial econometrics and they are very well known, from a mean average to the Arch-Garch family tests. So there are so many tests, so many specifications, we couldn't count on the fingers, and if someone memorized the whole number of the Garch model names, so you can say that it is a big thing. Because they are in thousands, you cannot say that this one is the final shape of the model, because they are varying with the specification, they are varying with the distributions, they are varying with basically there are two equations in the Arch-Garch type model.